Hello folks, AeroBlizz here, and finally I'm making an update on my pixel survival project, which has kind of been in a limbo for a long time. I mean, when was the latest video? I think it was almost 3 years ago, which I think is a long time. Well, things happened. So don't worry, the project is not abandoned. I won't do something like that. Yeah. There are some reasons. One, I've been busy with some other stuff. I hate those things. Work in dark to serve the light. We are. Shh. Night. Master Assassin Ezio Auditore is tired. Monkey Punch 2, Monkey Super Punch, Monkey Hard, Monkey Hit, Monkey Retreat, Monkey Smash, Monkey Do?
It's competitive. It has precise gunplay.
For the most part, and things like examinations, graduation, job, life happened. Well, aside from lame excuses, I was actually working on the project behind the camera, which I'll be discussing as we further go into the video, but there was actually a solid reason why this video got delayed. So if you may or may not have been watching videos on this channel, which I don't know what you're doing, I post game dev related content, really fun videos. So I talked about an incident which proved to be really fatal for my dev scene that was mentioned in this video, which if you haven't watched then you should watch, it's really amazing. Sorry about that. So I talked about the incident in this video, which was about how I made a sandbox building game, which you haven't tried, I highly recommend it, it's a really fun game. The great catastrophic failure of HDD1. Basically, my hard drive got corrupted. And fun fact, it contained all of my game projects. And yeah, that was very smart of me, to have all of my game projects saved offline in a single hard drive. So yeah, I was able to recover some data, but most of the game files had errors and I had to fix almost everything, which funny enough I'll have to do that anyway due to the state of the project. What I mean by that is this game's features a procedural generation system which makes top-down tilemap worlds. Now to do that, I used Unity's tilemap components and tile flow, which quite sucked actually. And I'm not saying they are bad, but they were not viable for my case. In fact, I would suggest using this to make finite tilemap worlds, as this is actually integrated in Unity, which makes it simple to set up. But my game would have an infinite world like Minecraft. And also, I plan on having heights in my game's top-down world. But I was experiencing some performance issues with Unity's tilemaps when having large map. And also, the proper chunking would be tricky to set up with Unity's tilemap. Now, as I said, I started refactoring the project a long time ago, so I exactly don't remember the issue with performance, but when I added heights in the game, my PC went something like this. Yeah, completely froze the PC when world starts generating. Now, it could be because of my code was all synchronous and making this much data in a single frame can lead to freezing. But still, using Unity's tilemap was like having things which wasn't needed, so I started creating my own tilemap system, which would be simple and I would have more control on it. And for the other freezing issue, we can use power of threads, CPU threads. So here comes multi-threading. Nowadays, we have multi-core threaded CPUs, so we can use other threads to perform operations for us without blocking the main thread. So currently, the game is experiencing some really solid freezing issues because it tries to create all of the noise and visual data in a single frame. So by making code asynchronous, we can let the game run smoothly, meanwhile generating our required data in the background. Then when we have our visuals ready, we can show chunk at that moment. Now games normally doesn't like to run multi-thread dirtily, and these are often due to various reasons: how the game loop works, the dependencies, race conditions, rendering, and the list goes on. But we can have some of our tasks utilize the benefits of asynchronous code. In our case, it's mostly creating the tilemap textures, but more on that later. So, how do we do that? Well, this wasn't exactly my first go-to process. I tried different approaches before this, like initially trying Unity dots. As you see, I was really fascinated by this demo from 2019, back when Unity used to showcase impressive things. Now it's just... well, Unity dots. It's a framework designed to maximize performance by using a different data-oriented approach. So, as it says, it gives performance, but I didn't go for it because of two main reasons. First, it was really complex to set up, and for now we need it for generating tiles. Although I'm thinking of ways in game for terrain to be customizable, destructible, but we don't need every tile to be an entity, so not a valid case. Another reason is it's still in preview, meaning it's not officially released as a package. But in future, it can be used as a valid case for things such as mobs, AI NPCs, units, and elements that can benefit for its ability to have in large amounts. But for now, no dots, or DOTS, whatever it is. Then, as you know, we are making our own grid system. We only need to show a texture on a plane. So how about we use UV coordinates to display our tile map? For example, we can have a texture having tiles assembled like this and use UV coordinates to display the required tile at the grid cell. Now this method is great, in fact most games use this, but we have a limitation here. There's only a number of tiles we can add within a texture. We can maybe use texture atlases or arrays for more tiles, but that's just another complexity added and we are still limited. And I'm shooting for the star here. In future, I want tiles to blend with each other seamlessly to deliver immersive visual experience. For example, let's say you have a snow tile on the left and a grass tile on the right. Now I want grass tile to have some snow overlay on it, and there can be a lot of elements in the play here, so I wanna have that freedom of choice in this. And that's why we are not using this method. Now to have that freedom, we'll need to generate the texture pixel by pixel in the game. We can do this efficiently with two ways here. One is we have a method called setPixels, which just applies color data on a texture. And the other way is using those fancy shaders, especially compute shaders. One is to use CPU to generate color data, and the other one uses power of GPU to generate visuals. So I set up a quick test to see which method is faster. Let's log the performance for generating color data for a 1K texture with 100 repetitions, which I know the shader will be faster. Well. There's actually no difference here. And as we only need to generate texture single time and not every frame, I think we'll go with setPixels. But we can use the shader for effects and other things, which is good because we can offload some tasks from CPU to GPU and... So now we have our method of generation. Now how can we use it in an optimized way? One is to always use setPixels instead of setPixel in a for loop, because it's better to apply all of your color data in a single go. Another thing I tried was using job system, which is Unity's way to handle multi-threading. But in this case, it was rather causing stutters instead of removing it. And that was because of the workflow. So what's happening was, in job system, you'll have to pass everything in a struct and using native collections. So creating and converting the data, then processing color info from tiles, and then after calculation, again converting that back to normal was causing more overhead issues. So job system is good for short calculations and doing those things continuously. It could be used for other things such as my game would need a height system, and it shines when we are calculating short tasks every frame. So it would be useful for navigation system in this pseudo height top-down game. But yeah, this one's for the future as well. And now finally, at last, we have finished to the point where we left off previously. Well, this time things are done more properly and in a more structured way. One of them is tile bit masking. In my previous video, I explained this bit masking system. Basically, by using information from adjacent tiles, we decide how this tile would look like. It was a straight multiplication with the powers of number 2, which resulted in 256 cases, which are kind of more, so I would have to be mindful for every case. But with the new smart bit masking method, a lot of redundant cases were removed, and it worked something like this. For example, if one of the above 3 tiles are not the same type, we can ignore the corner tile for their calculation, as it won't have any impact on the tile visuals. So this results into 45 cases, which are more manageable, and I have maintained them in a sheet. I've become very managed recently, at least in the ways of game dev. Heck, I even made a calculator for it. And also, I improved the generation workflow. Now a chunk generates the texture, but what about its corners? For that, it needs to know about adjacent chunks, but we are doing this asynchronously, so when? For that, what I did was, let's say initially, the chunk would just generate the texture like there's just air on the sides of it. Then, whenever the new chunk generation is finished, it broadcasts an event saying, "Hey, I finished now." The already generated neighbor chunks would respond to that and request, "Well, as you decide right to me, can I get the data for your left side of tiles?" And the broadcaster will send that to the receivers, and receiver chunk will update its visual. That's how it goes. That's how the map generation system works now. You can see the performance is consistent. We have some spikes in the profiler, which is just instantiating of tilemap game objects whenever chunk is generated, which would be removed with the introduction of polling system in the future. Yeah, again for the future. With that, I added another bit mask parameter for the tile using the above and the below tile, which helps us to make cliffs. It's pretty simple. If there's a tile above, show the cliff art, else ground art. And finally, we are reaching the heights. Currently, I've used a single image for the cliff tile, which can make some visual confusion, but it can be improved in the future. For the future, some of these maps were looking really promising, especially if you use less height levels. Also, increasing the noise scale really helps, as it makes the height more spreaded and eliminates the visual confusion. Of all things considered, I would say it's a rather good start. So this was all about terrain generation and height system, but there's one more thing I want to address in this video, and it's about the player visual system. Previously in my videos, I explained how the animation system and character customization works, and well, you'll be amazed to know how it works. And so the process is, let's say for one animation, first draw frames for each orientation, right, left, up, down, then create sprite sheet. But as we have different customization options, so draw frames for every body type, then create sprite sheet as well. Now wow, we have types for eyes as well. Draw frames, sprite sheet. Wow, we have body tones. Draw, then sprite sheets. Wow, we have clothing options. Draw, sprite sheet. For each clothing we have color variants, so draw, spreadsheet. We have second type of clothing, draw, spreadsheets, and do all of this again for the second body type and for each orientation. And yeah, spreadsheet as well. So this is the first phase. Here comes the second phase. In Unity, import sprite sheets, then cut them into tiles and name each of them. Then after that, add each of them in scriptable objects. Then repeat this for each of the customized options. What the f was smoking back then? So as you know, it wasn't a great workflow to begin with. Yeah, who are we kidding? It's terrible. I was dummy dumb back then. But every story has character growth. I had that as well. As this workflow is very time consuming, I improved this. So I need to make it as automated as possible. First was to remove drawing art as much as possible, and luckily I did find a solution for that. And guess what? Which thing helped us here? Shaders. I wrote a color swap shader, so what it does is it replaces color A into color B, and I guess that's what swap means. So what we can do is we can draw out animation frames in grayscale format, and in the shader replace grayscale values with an appropriate color. A point to note that I am using grayscale values instead of directly comparing colors because of performance reasons. Like comparing values of two colors, since they are float values, we can have some point errors, and if statements aren't generally good in shaders. So I made the first version of shader, which allows us to use for color, mainly outline, normal, shadow and highlight. But as clothing can have some extra details, so change that with using a palette texture, which is more dynamic and allows for more options. And it works something like this. Let's put grayscale and texture side by side. You can consider grayscale as a single value ranging from 0 to 1 and the dimension of texture as well 0 to 1. Now you can directly replace the corresponding values to get the color. So all I have to do is draw frames for body types and clothing options. By the way, I've also started using AeroBlizz for all of my pixel art. It's actually much better suited than Photoshop for pixel drawing. It also has options to create sprite sheets faster and is very affordable, doesn't cost a whole lot of fortune. So I draw them in grayscale and palettes for them, and the shader handles the rest. With this, I can also add more variants of an item pretty easily. I'll just have to export a palette texture for it. And I store all of this in scriptable objects, which are a great way to store and manage data in Unity. The only one thing I did good previously. By the way, I also told you about how I used to manually cut sprites and name them, which could arise some problems, some genuine problems. Like, see this, now accidentally, I have shifted the rect of the sprite and now that frame will appear with incorrect position and the animation is. But I was able to solve this in this huge time gap, yeah, pre-hard drive corrupt incident, for my previous sprite workflow. So I used to have a script which automatically takes all the spreadsheets, cut them, name them and create assets, which was really amazing. I used to call it Spritinator. Sadly, I don't have the footage for that because of hard drives. But I did create a mini version of it, which saved me a lot of time. And lastly but not least, I also refactored the customizer UI code as well. Now the code is not spaghetti, it's more of a mystery casserole. You are not quite sure what's in it, but it works most of the time. Just kidding, it's pretty solid and follows good principles. The UI layout could get some work on it, but it's not final design, it's a prototype which can be improved in the future. And with this, we are finally finished. But before that, there's one very important thing I like to do first. Yeah, I don't want to repeat that mistake, still got a PTSD from that. So that's why I uploaded the project to Git. And I think that's it. From now on, we are gonna do things properly. So thank you guys for watching. I hope you liked it. Let's do the usual formalities. Subscribe, watch my other videos as well. And you can suggest me things in the comment section. And yeah, until next time.